Hello class. In this video, we continue talking about truth tables. Last video, we covered truth tables for negation, conjunction, and disjunction. And today, we are going to talk about truth tables for the conditional and biconditional statements. Let's recall conditional statements. P implies Q, or if P, then Q. Which statement is the antecedent? Which one is the consequent? P here is the antecedent. Q here is the consequent. Yeah, to make a conditional statement, we need two component statements. The one right after if or before the implied symbol is the antecedent. The one after the symbol is the consequent. How do we make the truth table for P implies Q, this conditional statement? We are going to talk about an example, all right? Yeah. So here P is going to be you study 5 hours every day. That's you supposed to in this course, for this course. Q here is you get A from this course. So me as the professor claim, Betty claims if you study 5 hours every day, Monday, Tuesday, Wednesday, Thursday, Friday, if you study 5 hours every day, then you will get an A from this course. That's my claim. Well, let's look at the 4 cases. Let's look at the 4 cases. In this conditional, we have 2 simple statements, right? P and Q. Then P and Q make 4 cases. Case 1, case 2, case 3, and case 4. Remember the order of the 4 cases. TT, TF, FT, and FF. Let me label the 4 cases. 1, 2, 3, 4. Okay? And we are trying to figure out the truth value for this conditional statement P implies Q. If P, then Q. Yeah, you are going to judge what Betty claims, true or false, logically. Well, now let's look at the first case. Let's say Andy. Andy study 5 hours every day. And Andy, by the end of the semester, receive a grade A from the course. So what do you think about my claim? Yeah, Andy will be happy with my claim, right? Because the teacher says, if you study 5 hours every day, then you receive an A. And he did it. He studied 5 hours a day and he got an A. So that makes my claim true, right? In Andy's case, my claim is true for sure. My claim is true. Okay. So let's look at Bobby, the second case. In Bobby's case, he studied 5 hours every day. So P is true. However, he did not get an A. Yeah, he did not get an A. So what do you think about Bobby? Would be Bobby happy with my claim? Because I said if you study 5 hours every day, then you should receive A from the course, right? But Bobby studied 5 hours and he did not end up with an A. So Bobby will think the teacher is wrong logically, right? Does that make sense? So that makes my claim false. In Bobby's case, my claim is false. In Bobby's case, my claim is false because I said if you study 5 hours every day, you get A. And Bobby did it. Bobby studied 5 hours every day, but he did not get an A. So in Bobby's case, my claim is false. Case 3 is about Cindy. Cindy did not study 5 hours every day. P is false, but Q is true. So in Cindy's case, she did not study 5 hours every day, but he got an A by the end of the semester. What do you think about my claim? The claim I made at the beginning of the class, the semester. That would still make my claim true, right? Because nothing is wrong with my claim logically. In the case of Cindy, I said if you study 5 hours every day, you got an A, right? I don't care. I did not say what will happen if you do not study 5 hours every day. So since the antecedent does not hold, what happened? The P does not happen for Cindy. So doesn't matter what is the Q happen or not happen. It does not make my claim false logically. Does that make sense? And the last case is Danny. In Danny's case, both P and Q are false. Danny did not study 5 hours every day. Danny did not get an A by the end of the semester. And in Danny's case, my claim is still true. In Danny's case, Danny cannot say what I said is wrong because he did not study 5 hours, right? So whatever happened, the consequence is it doesn't make my claim false logically. So I would recommend that you pause or repeat this part and really make sense why we have a truth table for P implies Q like that. And what you need to remember is this sentence. For a conditional to be true, for a conditional to be false, the antecedent has to be true and the consequence has to be false. As you can see in this truth table, only in Bobby's case, my claim is false, right? Let me repeat this very, very important sentence regarding the truth values of a conditional statement. For a conditional to be false, the antecedent has to be true, but the consequence has to be false. And in all other 3 cases, conditional is true. There's only one case in which a conditional is false. That is when the antecedent is true, but the consequence is false. I guess some of the students will have a question about this example. So I would recommend you repeat this part of the video. Really try to make sense of it. You're judging if my claim true or false logically. My claim is only false in Bobby's case. Bobby would be the only person who is not happy with me. He studied 5 hours every day, but he did not pass with A, right? All other 3 cases, they will not have any problem with my claim. Okay, let's practice. Let's use the truth table for the conditional. Here, we are going to construct a truth table for not P implies not Q. Let me double check. I'm not muting myself. Perfect. Okay, we are going to construct a truth table for this conditional statement. All right? This conditional statement. The antecedent of the conditional statement is not P. The consequence of the conditional statement is not Q. Since this compound statement, conditional statement, involves 2 simple statements only, the first 2 columns on my truth table would start from P and Q, follow with the 4 cases, right? 1, 2, 3, 4. T, 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 F, F, T, F, F. Okay. You know, let me redo this table. It's not very nice. Draw a better table. 1, 2, 1, 2, 3, 4. Column 1, column 2. P and Q. TT, TF, FT, FF. Okay, so remember my table, once the structure of the table is set up, I always start from the last column. I would use the last column for the target statement. My target compound statement is not P, implies not Q. All right? And it is conditional. This compound is conditional. This conditional has, and we actually don't need many columns here. We only need 2 columns here. Yeah, you need to do the same thing on your scratch paper. So the antecedent, yeah, antecedent is not P. The consequent is not Q. All right, yeah. Antecedent is not P. Consequent is not Q. Yeah, antecedent implies consequent, gives us the target conditional statement. Yeah, this is the structure of this truth table. Let's fill in the blanks. Look at the column 1 and column 3. Those 2 columns should have opposite values. When P is T, not P is F. TF, FT, FT. Yeah, this column and this column, they should have opposite truth values. Negation. And now let's look at not Q. So we look at the column 2 and the column 4. TF, FT, TF, FT. Yeah. Second column and the fourth column, those 2 columns are negation of each other. They should have opposite statement, opposite truth values. TF, FT, TF, FT. Okay, perfect. And now we are ready to write the truth values for the conditional. For a conditional to be false, the antecedent has to be true, but the consequent is false. Okay, there we go, here. For a conditional to be false, the antecedent has to be true, and the consequent is false. So TFF, how do I remember that? Or I recommend you, maybe you want to remember true trusted friend. What is it? Trusted, true friend, trusted. TFF. Trusted friend. Oh, what is my table note? Let me give me 1 second. Let me find my table note. And also, this is how do I show you? How do I find my table note? So Betty's table notes. Chapter 3. And this is chapter 1. Trusted friends forever. Okay, now I remember. Okay, let's go back. Yeah, trusted friends forever. Yeah, you might want to use that as something that you can remember in the case, which case? There's only one case in which the conditional is false. It is a trusted friends forever. Okay, yeah, only trusted friends forever. All other cases are temporary. Yeah, that means this is a temporary, this is temporary, this is temporary. Only trusted friends forever. So now we have the truth table for this conditional completed. Yeah, very, very important. The truth value of a conditional depends on the truth values of the antecedent and the consequent. There's only one case in which a conditional is false. Yeah, trust the friends forever. Only when the antecedent is true, but the consequent is false, the conditional is false. Only trust the friends forever. All other cases are temporary. Biconditional. You need to remember, for a biconditional to be true, the two component statements must have the same truth values. Yeah, because P if and only if Q means they are equivalent, right? Yeah. In order for that biconditional to be true, the two components have to have the same truth value. As you can see, when they are both true, the biconditional is true. When they are both false, the biconditional is true. When they have different truth values, the biconditional is false. Yeah, please make effort to memorize those stuff. Again, we have 1, 2, 3, last video 2 today. So in total 5 basic truth tables: negation, conjunction, disjunction, conditional, and biconditional. You need to memorize those 5 tables. Next, we have some special cases. A compound statement is called self-contradiction if the statement always false in all cases. A compound statement is called a tautology if the statement always true in all cases. So just some definition. An implication is a conditional statement that is always true. Yeah. Implication is a conditional tautology. Here, the guided note mentions the dominance of those connectives is very important when you construct a truth table for the given compound statement, because the first thing you need to do when you construct the truth table for a compound statement is to see the structure. Yeah, once again, biconditional has the top level of dominance, followed with conditional. Conjunction and disjunction have the same level of dominance, and negation has the weakest dominance. Example: construct a truth table for the given statements. Determine whether each statement is a tautology, a self-contradiction, or neither. Remember, what is tautology? The statement is true no matter what, right? In all cases. Self-contradiction is a compound statement that is false in all cases. Okay, so let's see what's the structure of this compound statement. One component, yeah. Conjunct with another component. You might say, isn't you just mentioned the conditional has a higher level dominance than the conjunction? Yes, it's true. But did you notice there's a parenthesis here? There's a parenthesis here. The grouping symbol implies P implies Q is one component, the first component in this conjunction. Right? In this conjunction. So the conjunction, the truth value of this conjunction. Hold on. Make it this thinner too. Conjunction. This conjunction, the truth value of this conjunction depends on the two components. components. This is the first component, this is second component. Yeah, this is truth table consistent with my style. Yeah, the two components preceding the target statement. Okay, let's fill in the blanks. Since the target statement contains two simple statements, we only have 4 cases. Yeah, we have seen this a lot. TTTF, FT, FF, 4 cases. All right, so if you think the column 3 is challenging, how about let's do the column 4 first. When P is T, not P is false. When P is T, not P is false. When P is false, not P is T. When P is false, not P is T. So this column 1 and column 4, they need to have the opposite statement, truth values. Okay. And now let's look at column 3. Column 3 is P implies Q, or if P then Q. The antecedent, this is antecedent. It doesn't let me write. So P is the antecedent, okay? And Q is the consequence. Q is the consequence. Oh, this is the sparkling one. Okay, so this is antecedent. This is the consequence. For a conditional to be false, antecedent has to be true. Conditional consequence has to be false. Okay, yeah. So do we see trust the friends forever? In the second case, trust the friends forever, right? In all other cases, temporary, temporary, temporary. Okay, that's column 3. You can pause or repeat this part. For a conditional, column 3, this column has antecedent P, consequence Q. For that conditional to be false, P has to be true, Q has to be false. So that's the second case. And in all other 3 cases, the conditional is true. Okay, now we are ready to take care of the conjunction. Remember, for a conjunction to be true, both of them has to be true. For a conjunction to be true, both of them have to be true. So the last 2 cases, right? Yeah. For a conjunction to be true, both 2 components have to be true. And all other cases are false and false. And that's how do we get that truth table completed. Number 2. Now what's the structure of this given compound statement? It is a conditional. Same reason. We do have a compound state. We do have a biconditional, but the biconditional is in the parentheses. You know what I'm saying? Yeah. So this biconditional is in the parentheses, is grouped. So as a group, it is the antecedent of the conditional, and Q here is the consequence of the conditional. All right. And this truth table also have the antecedent and the conditional right in front of the antecedent and the consequence right in front of the conditional. Yeah. So we need to remember. This is antecedent. This is a consequence. Okay. And Q is given here. And we need to figure out P if and only if Q. The antecedent is a biconditional. Remember, how do we, what sentence we need to memorize for the truth value of a biconditional? For a biconditional to be true, the 2 component statements must have the same values, right? Yeah. So they have the same value here. They have the same value here, and all the other 2 cases are false. TFFT. For biconditional to be true, both the 2 components has to be have to have the same truth values. Okay, so now we are ready for this conditional. This is a conditional. For a conditional to be false, yeah, only trust the friends forever. The antecedent needs to be true. The consequence needs to be false. Do you see that? Do you see trusted friends forever, right? Yeah. All other things we do not have trusted friends forever. So those are gonna be just temporary. TTT. For a conditional to be false, the antecedent has to be true, but the consequent is false. And in our case, only the case 4. The fourth case we have false. All other 3 cases are T. Number 3 is a very complicated compound statement. The important thing is we see through the structure. Yeah, the important thing is to see the structure. You see this bracket? The whole bracket group the whole thing here as one component, and this is another component. So the structure of this compound statement is a biconditional. Okay, biconditional. Biconditional. So this is the first piece in the bracket, and this is the second piece in the parentheses. And last column is a biconditional of those 2 components. And we need to figure out the truth value for each component. Okay, so for this guy, which guy? This one, the first piece. Yeah, let's figure out what is the first piece. The first piece is a disjunction. The disjunction has 2 components. The first component is P implies Q, conditional. The second component is P and not P and not P. P and not P. Okay, P and not P. So this is the first component. This is the second component of that disjunction. So we need to find the values for those 2 components in order to fill in this column. All right, let's do that. Okay, P implies Q, conditional. Trust friends forever. Trust friends forever. P implies Q is false only when P is true, Q is false. All other cases T. All right, and column 5. Yeah, this column. Yeah, let's figure out this column now. P and not P. Yeah, so the 2 components are P and not P. P and not P. P and not P. So we have to figure out not P as well. So those 2 columns should have opposite values. Column 1, column 4 need to have opposite values. And then they are going to do the conjunction. So this is column 1, 2, 3, 4, 5. Yeah, column 5 is a conjunction of column 1 and column 4, right? So for a conjunction to be true, both of them need to be true. So I'm looking at column 1 and column 4. None of them have both true. So that means this is all false. False. Okay? Yeah, think about why. Why P and not P is a self-contradiction. P and not P, think about. Because it's not possible for P and not P both true. Because they must have opposite same values, right? Yeah. So P and not P is a self-contradiction. Okay, so now we have the 2 pieces. Yeah, so this is column 6. column 6 is a disjunction of column 3. Oops. And column 5. Column 6 is a disjunction of column 3 and column 5. All right. For a disjunction to be false, both of them need to be false. So this is false. All other are true. Let me double check. So column 6 is 3 or 5. 3 or 5. So we only have the second case, both of them are false. For a disjunction to be false, both of them need to be false. Okay, very good. All right, so that's the first piece of the target statement. Second piece is not Q. So let me label this number 7, number 8, number 9, number 10. Number 8 is 7 implies 4. Number 8 has antecedent 7, consequent 4. So let's fill in the column 7 first. We look at column 2 and column 7. So opposite F, T, F, T. So column 2 and column 7 have opposite truth values. Okay, so in order for 8 to be false, we need a 7. So you can see this is a little bit awkward unless you have this written. Otherwise, it's very, very not convenient. So look at here. In order for 8 to be false, 7 needs to be true, but number 4 needs to be false. Do you see that? Yeah, in the second case, the antecedent is true, but the consequent is false. So trust the friends forever. And you should look at the 7 first and then number 4 after. And all other, we do not have trusted friends forever. So all other cases are T. Okay, so number 10. Number 10 is the biconditional of, we don't have number 10, it's number 9 actually. The last column is the target, number 9. Number 9 is number 6, if and only if, number 8. All right, so let me color those 2 columns as yellow. This and this. Biconditional. For the biconditional to be true, the 2 pieces needs to have the same truth value. So the case 1, yes, they have the same truth value. Case 2, yes, they have the same truth value. Case 3, yes. Case 4, yes. Okay, this is a tautology. Tautology. Yeah, the statement turns out is a tautology because it's true in all cases. Number 4 is a conditional. Okay, so conditional. So let me label. This is column 1, column 2, column 3, column 4, 5. 6, 7, 8, 9, 10. Yeah, it's a very big table. Very big table, pretty complicated. Number 10 is number 6 implies number 9. Number 10 is number 6 implies number 9. So the two pieces we need to pay attention is this one and this one. Okay? Yeah, the targeted compound statement includes 3 simple statements. That's how do we have 8 cases. Okay, so whatever the columns we need is already in the table. So we're going to fill in the blanks. Number 4. Number 4 has antecedent P and consequent Q. So number 4 is conditional. We are looking for trusted friends forever. We are looking for trusted friends forever. And all the other cases, they are temporary. Yeah, let me double check. Number 4 has number 1, column 1 as antecedent, column 2 as consequent. So we only have case 3, trusted friends forever. Case 4, trusted friends forever. All other cases are temporary. Okay. So column 5. Column 5 has Q. This is antecedent. This is consequence. I need to color them in order not to see the wrong. So, so Q is antecedent. This is the antecedent. And R is the consequence. Let's see. Trust the friends forever. Trust the friends forever. Trust the friends forever. All other cases are T, 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 T. Okay, let me double check. Trust the friends forever, case number 2. Trust the friends forever, case number 6. Yeah, that's correct. And now let's look at column 6. Column 6 is a conjunction of column 4 and column 5. All right? So for a conjunction to be true, both of them have to be true. So both of them have to be true. Both of them have to be true. Both of them have to be true. Yeah. For column 6 to be true, for the conjunction to be true, number 4 and number 5 have to be both true. This is both true. This is both true. This is both true. Both true. And all other cases are false, 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 false. Yeah, we have one piece taken care of. Now let's look at column 7. Column 3 and column 7 should have opposite values. So F, T, F, T, F, T, F, T. So column 3 and column 7 should have opposite statements. TF, FT, TF, FT, TF, FT, TF, FT. Okay, so don't be afraid, always double check. You should always double check, just in case if you mess up one detail, everything would be different. And column 8 is the opposite, the negation of column 1. So F, 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 T, 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 T. Yeah, the first column and the 8th column, they are negations, so they should have opposite. T, 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 F, 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 T, 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 T. Okay, that's correct. And now we are going to take care of column 9. Column 9 have antecedent 7, consequence 8. All right, so we are looking for trust friends forever. Trust friends forever. Trust friends forever. So trust friend, this is a trust friend forever. This is not temporary. Trust friends forever. This is not temporary. Trust friends forever. Temporary. 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 Okay. Okay. So now we have. Yeah. Let me double check. So not R. Number 7 is the antecedent. Number 8 is the consequence. Trust the friends forever. Trust friends forever. All other cases are not. Okay. So column 6 and column 9 together make column 10. And column 10 is 6 implies Q. Okay. Yeah. So this is antecedent. Yeah. Column 6 antecedent. Column 9 are the consequence. Column 9 are the consequence. Okay, so we are looking for trusted friends forever. Oh, we don't have. Yeah, let me go over again. Trusted friends. We don't have a trusted friends, so they are all temporary. T, 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 T. Because we do not have a trusted friends, so we do not have forever. They are all temporary. So this is what? Tautology, right? And it's a conditional tautology. What is it called? What is that called? Implication. Implication. Okay, so let's see if we have more question here. Example: determine the truth value if P is false. We have one more. Those are good exercise. P is false. Q is true. R is false. Yeah, we need to determine the value for this negation. Okay, this is a negation. The bigger structure is negation. So we need to look at whatever in the bracket first. In a bracket, we have a biconditional. We have a biconditional. And this is the first piece. This is the second piece. Yeah, let's go by piece. Let's go by piece. The first piece is not P implies R. Not P is the antecedent, R is the consequent. So P is false, then not P would be true. So trusted friends forever. Yeah, so this conditional has true antecedent. False, R is false. False consequent. So the conditional is false. Okay, trusted friends forever. So that is that. Now let's do the second piece in the biconditional. You might think this is so troublesome. You don't like it. You have to take test 1. This is a lot of questions in test 1 is from chapter 3. So you need a study, learn a content. So Q is true, then not Q is false. P is false. P is false. P is false. Not Q is false. A disjunction, yeah, P is false, not Q is also false. For a disjunction to be false, both of them need to be false. So this piece is false as well. So the two pieces, the two components in the biconditional, both are false. They have the same values. So the biconditional in the bracket is true. Okay, the biconditional in the bracket is true. And negate that, we have false. So your final answer is false. Yeah, I mean, the truth value for the given compound statement is false. Yeah, it might be might be challenging for some of you, uh, but it's something you have to take it seriously. Please feel free to email me if you have any questions. I'll see you next section.